time to time, a sea current brings death to the Galapagos Islands. El Niño, a meteorological phenomenon which is becoming notorious all over the world, heats up the waters on the Pacific coast and causes terrible death and destruction to animal species. But Galapagos is not dying. The arrival of El Niño is just a part of the ancient cycle of death and rebirth, a reminder of its genesis and a repetition on an infinitely smaller scale of how life colonized these islands and transformed them into an earthly paradise. A fissure in the Earth's crust. The boiling, burning material from the center of the Earth bubbles up to the surface. Iron, sulfur and silicon at over 1,000 degrees centigrade. Something like this must have been the origin of the Galapagos Islands, but with one difference. The birth of the Galapagos Islands occurred underwater. At first glance, the landscape could not seem more desolate. A handful of burnt-out islets, almost 1,000 kilometers away from the nearest coast. It seems impossible that life could reach this land of volcanoes, and yet from the very moment that they appeared on the surface 5 million years ago, the Galapagos started to prepare themselves to house life forms. Erosion. This was probably the first step. Winds and water currents broke up the volcanic rock in a gradual process in which enough level of soil was formed for a seed to germinate. The wind and the water joined forces in this job. Not only did they erode the rock and so create soil, but they also brought real specialists from the continent that accelerated the process. Algae and lichens split up the rock, forming sediments and eventually soil. Then the chain became unstoppable. This is Brachytherius, a specialist in the colonization of lava. It hardly needs soil to survive, but its little roots work on the lava by fragmenting it in such a way that a path is cleared for more complex plants. But how did the Brachytherius seed reach this lava? And an even more difficult question to answer: how did animal life get here? The Galapagos arose from the sea, so unlike most islands, they never had any contact with the continent. All the living creatures that inhabit these islands had to cross 1,000 kilometers of sea without fresh water and exposed to the equatorial sun to reach these new desert islands. Seabirds must have been the first visitors to the Galapagos Islands. They have more than sufficient strength to arrive here from the continent, and the trade winds must have made the journey easier. At that time, the islands must have had no life whatsoever, but this did not concern them. If truth be told, it actually worked in their favor. Frigate birds, seagulls and gannets, like so many other seabirds, found their food in the sea and used the barren volcanic rocks as stopover points where they could get their strength back. But as there were no enemies or predators from which to protect themselves, it was also a wonderful place to hatch their eggs, especially for those species that lay their eggs on the ground without even bothering to make a nest. Birds such as these blue-footed boobies or those that nested on the rocks must have been the first to breed in the Galapagos. In the beginning there were no trees, so birds that made their nests in branches had to wait until the vegetation became more complex. A process to which the birds themselves contributed by bringing seeds that had stuck to their feathers or legs, or in greater quantities in their stomachs, from which they ejected them in their feces. Even before the complex plant world of the Galapagos had developed completely, the first land-based vertebrates must have arrived from the sea. Pieces of wood, pieces of continental vegetation, or hollow light trunks became floating islands on which some animals managed to cross the sea from the continental coasts. It was very difficult for amphibians and mammals, but among reptiles, real specialists in desert conditions, success eventually arrived. Land iguanas could well have arrived sailing on floating logs. This must have been the case at first, although they only managed to colonize the Galapagos when plant life provided them with a source of food. Opuntia, one of the many species of giant cactus that inhabit the islands. The fruit and the cladode of the Opuntias are the main source of food for the land-based iguanas of the Galapagos Islands. Its tissue structure conserves water and the reptiles obtain food and water at the same time. The fruit contains the seeds, which are protected by sharp spines, but the iguana's scaly mouth is designed to conquer these defenses. And in the long term, the cactus also benefits. As a payment for the food, the iguanas excrete the Opuntia seeds on their travels around the islands, and so the giant cacti gradually colonized new territories. When the Galapagos plant life allowed birds that nested in the trees to breed, a rapid process of colonization occurred, which has continued until today. And, as might be expected, the first settlers were seabirds. A colony of frigate bird young. Few birds make such spectacular efforts to find a mate. In what will be the nest, the males make their gullet sacs swell up to attract the female's attention. This process involves an enormous use of energy, but the effort is worthwhile. The female frigate birds only hatch every 2 years, and they only lay one egg, which makes them more demanding when it comes to choosing a mate. The aim of the male's display is to show the females how strong and resistant they are, two qualities which they will need when it comes to bringing up their small number of offspring. The only chick will take from 7 to 8 weeks to raise, and the parents will have to take turns at the work. The job is so hard that each week in the nest, the adult on duty loses a fifth of its body weight, which means that only the strongest survive, and these are those that make the most dramatic mating display. The blue-footed boobies are much more prolific. The nest is little more than a clearing in the sand in which they will lay 2 or 3 eggs. Incubation on the ground has its disadvantages. Heat without any protection in the shade is terrible and may be dangerous. But the boobies have learned some tricks to make the stifling heat more bearable. The so-called gula ventilation is one of these tricks. A quick movement of the folds of the skin under their beaks generates a current of air that evaporates humidity and cools them down. Also, the self-sacrificing parents know how to make use of currents of fresh air. When the wind gets up, they position their bodies so that when they fluff out their feathers, the breeze cools their backs. The birth of the chicks occurs in sequence, as does the laying, with a period of 3 to 5 days between them. This has a terrible but practical purpose. If there is a good year and there are plenty of fish, the boobies can raise 3 chicks. But if there is a food shortage, the largest chick will receive all the food and the others will gradually die off according to their size. A dramatic way of ensuring the survival of the greatest possible number of offspring. The boobies also have a dramatic mating display, but that of the Galapagos albatross is even more complex and spectacular. At 4 or 5 years of age, the albatrosses return to the island Hispaniola to find a mate. These birds can live for 50 years and they mate for life, so the choice of a partner is a crucial time for them. Courting is governed by a very complex ritual that seems to combine dance steps with occasional fencing contests. Not only the young participate in courting. Couples that did not manage to raise any young the year before join in this extraordinary dance, and the occasional bachelor bird dares to try to steal another's partner. After finding a mate, the albatrosses return to the same place year after year to reproduce, and, as in the case of the boobies, lay their eggs on the ground. Incubation lasts for 2 months, and both adults take turns. In Galapagos, there can be no room for error when caring for an egg. An albatross goes out to fish and leaves her vulnerable eggs for a few minutes. The egg is a source of food and water, and the mockingbirds know it. Once the eggshell is broken, the larva lizards take advantage of the occasion. also an irreplaceable source of calcium for them. However, in spite of the apparent tragedy, everything forms part of an overall balance. The mockingbirds have also hatched, and their chick will benefit from the energy-filled albatross egg. In Galapagos, it is easy to see how each animal depends on the species that share its territory. But there is something common to all of these species which goes beyond the frontiers that mark each one of the islands, a life support system shared by all life in Galapagos, the sea. Under the waters that bathe the Galapagos archipelago, there are an infinite number of habitats brimming over with life. Unlike the islands, these are open systems and many species pass from one to the other without encountering any physical obstacles. This natural wealth is due to the particular conditions of the Pacific Ocean in the Galapagos area, where the trade winds and the ocean currents combine to create an annual cycle with slight variations. Cold waters arrive in the Peru current from the south, the Cromwell equatorial current from the west, and the Panama current from the north with warmer waters. The first penguins must have arrived by sea from the frozen waters of Argentina and Chile. The Galapagos penguins descended from those penguins of Humboldt and Magellan. This is the only one of the 18 species of penguins that appears north of the equator and nests only in the tropics. The wealth of the cold waters of Galapagos was the key to the origin and survival of this penguin. The icy waters from the south provided the microscopic nutrients, and the rest of the trophic chain came after them. A chain of life that ends up outside the water. Sea lions are the most common mammals in the Galapagos Islands. The floating islands that brought the reptiles hardly transported any mammals. There was no water available, so the 2 weeks that it would take for a raft to drift from the continent to these islands was too long for most mammals to survive. But the sea lions did not come in rafts, they swam. More than 50,000 sea lions live in the archipelago area and live mainly on fish, an almost insignificant effort for the rich waters that prosper from the coming together of different currents. There are two species in the Galapagos. One, the fur seal, came with the cold waters of the south, the same waters that brought the penguin. It is the smaller of the two and is related to the fur seals that still inhabit the waters and coasts of Argentina and Chile. But its close relative, the Galapagos sea lion, is more numerous. The first members of this species must have come from the northern hemisphere, from the coastal waters of California. And in keeping with their origins, it is not uncommon to find them enjoying a day's surfing. Sea iguanas depend on the sea for survival, just like the sea lions. First thing in the morning, they gather in large groups near the water, letting the sun warm their bodies and activate their ecothermic metabolism. When their temperature has risen sufficiently, the sea iguanas go to the breaker areas or the intertidal area in search of the algae on which they feed. These are the only iguanas in the world that go into the sea. Their life depends entirely on the supply of algae that the ocean offers them, so they have become excellent swimmers. The sea iguanas feed on the algae on the shores while they can, but if these start to run out, they enter the water and dive down to the bottom of the sea, propelled by the powerful muscles in their flat tails. But this is only the beginning of their amazing adaptive achievements. A metabolism that is capable of working without renewing the oxygen supply and the ability to reduce their heart rate at will allow these sea iguanas to immerse themselves at depths of up to 12 meters for at least an hour. On many occasions, the most succulent, leafy algae are to be found in the breaker area. This is a considerable obstacle for young iguanas, but adult iguanas in the prime of life have no great trouble in reaching them. Sharp claws capable of withstanding the beating of the waves manage to keep them between the breakers and let them reach the algae successfully. From time to time, in cycles that are becoming even shorter and more unpredictable, the trade winds from the southeast stop blowing. Without the break of the Peru current pushed by the trade winds, hot water advances towards the archipelago and causes a tragedy with effects that go beyond the ocean limits. The rise in the water temperature causes an impoverishment of the marine ecosystem because the nutrients that arrived with the cold waters from the south disappear. The fish leave, and as a result of all this, death and starvation reign over all the Galapagos. El Niño, as this phenomenon is known, damages the coasts of the archipelago to such an extent that it would seem impossible for them to recover. But if the Galapagos have shown us something, it is that their power to shelter life has no bounds. With the return of the cold waters rich in nutrients, the zoological communities are reborn and their previous population levels gradually return. It is as if the islands wanted to resume and remember their biological capacity, the same capacity that transformed these barren islets into the epitome of biological evolution that they have become, but in a timescale that is 5 million times faster. The El Niño phenomenon is not as damaging for all species. If truth be told, once it has passed, it leaves some positive results behind that should be set against the negative effects in an overall balance. After all, we are talking about a phenomenon which is as old as the islands themselves. While El Niño sows death along the coasts, it causes torrential downpours inland. Fresh water is a necessity in very short supply in the islands, so the rains have a positive effect in the long term. The vegetation grows spectacularly, the number of insects increases, and birds reproduce in an exceptional way. Just as the years of drought created terrible pressure on the natural selection of living creatures inland, the El Niño years do so on the coastal species. In this way, the Galapagos have set the patterns for the evolutionary formation of species for the 5 million years that they have existed, and they are still doing it. The islands are isolated from each other and from the continent, and this has turned Galapagos into a natural laboratory that is unique in the world. The species that flew here were transported by animals or floated on the sea, became isolated by the stretches of water that separate the islands, and thousands of years of evolution adapting to different environments transformed them, so they diversified and created different adaptive models. In no other place in the world can this be seen with such clarity, and it only needed the arrival of a man of open mind like Darwin for the theory of evolution to arise here, a theory which would transform the very pillars on which science was built. And the process is still going on. A strange paradox if we bear in mind that Darwin originally intended to confirm with his voyage the fixed truth of the book of Genesis from the Bible. In the different islands of the archipelago, it is not uncommon to find new experiments in this monumental laboratory. This is a hybrid iguana. Its father is a sea iguana and its mother is a land iguana. There are only two in the whole world. Perhaps the prototype may work because its range of foodstuffs is wider than that of each of its parents, and its hybrid physiology means it can operate both on land and in the sea. But, as with so many other hybrids, this experiment is sterile. To reach new species, a gradual evolution over thousands of years is necessary, in which the environment shapes the physiological changes out of pure natural pressure. The Galapagos cormorant is a good example. Of the 29 species of cormorant that exist in the world, this is the only one that has lost its ability to fly. Here in the solitude of the archipelago, where there are no predators to escape from and the water offers a plentiful supply of food on the shore, flight is unnecessary for these cormorants. Or at least, not as necessary as the ability to swim to catch fish. So the cormorants that could swim the best ate more and raised more chicks. The result was the flightless Galapagos cormorant, a cormorant whose wings slowly withered in order to acquire a more hydrodynamic body, to the extent that they also lost the keel of the sternum, the place where the powerful muscles necessary for flight come together. In exchange for its loss of flight, this cormorant became an excellent diver. While hunting, it rarely strays more than 100 meters from the coast and has no enemies on land, so it does not miss flying. During the breeding season, the cormorants are suspicious and aggressive to those they see as enemies for their chicks or possible competitors for food in their territorial waters. In spite of their difference in size, the bird's bad humor seems to persuade this sea lion that it would be better to prowl on any other species of coast. While the sea lions are their main competitors for fish, the greatest risk for the cormorant's chicks comes from frigate birds. The frigates can catch newborn chicks from the air or steal the food from the hungry, impulsive infants that are too big to be preyed upon. Life in the sea or on islands where fresh water is short makes salt accumulation a problem. Most land-based vertebrates eliminate it through their kidneys, but 2 liters of urine would be necessary to excrete the salt content of just 1 liter of seawater, so those that ingest food and drink under the ocean waters have had to resort to more sophisticated systems. These flightless cormorants are getting rid of excess salt. They have special glands above their eyes that secrete a saline solution with a concentration of 5%. To prevent this secretion from falling into their eyes, they have a special duct which takes the drops to the tip of their beak, from which they fall in a constant drip. The sea iguanas have the same problem, but do not have a beak along which they can channel the salt excretion, so they have adopted a more efficient method. Their desalinating glands are the most effective of all reptiles. Like the cormorants, they are located above their eyes, but instead of the duct connecting with the beak, in iguanas it connects with the nasal orifices through which it ejects the salt by sneezing from time to time. This is why the sea iguana's head always appears with an uneven white helmet. The sayapa crabs also suffer from a diet with excess salt, which they have to eliminate. To do this, they have followed the iguana's method and have added an important improvement, namely jet propulsion. Salt is a double problem for the frigate birds. Not only must they excrete it like other seabirds, they must also get it out of their feathers. The frigate birds do not plunge themselves into the seawater. Only their beaks touch the water when they are fishing or when they steal what other birds have caught. The reason lies in the feathers themselves. The gland with which birds grease their feathers is very small in frigate birds, so if they landed on the sea, they would be soaked quickly and they would drown. But as they are constantly splashed with seawater, the frigate birds end up having to eliminate the salt deposited on their feathers. They do this by having a bath in fresh water. On the island of San Cristobal, the crater of an extinct volcano has provided a place for a lake. The frigate birds come here to desalinate, but they try not to immerse themselves completely in the water, and if they do, they have only a few seconds before their badly greased feathers are soaked and become too heavy for them to fly. A dispute between two females in reproductive phase ends up with one of them in the water. Its opponent knows that if it floats for too long on the water, it will drown, and so tries to prevent it from taking off. One last effort frees the female from the water. For frigate birds, desalination can be a risky business. The isolation of the islands caused the species to diversify, but it also creates very high risks for them. The arrival of new settlers adapted to the brutal natural competition on the continent may bring about dramatic changes within the fragile ecology of the Galapagos. These new introductions occurred on such a sporadic basis that they were absorbed over thousands of years. But the arrival of man changed the most important factor in this complex equation: time. Although it is likely that the Galapagos were visited by pre-Columbine sailors, it was officially discovered in 1535 by Fray Tomás de Berlanga. From then on, man started to interfere with the natural balance of the archipelago. New species arrived on his boats deliberately or otherwise, and they arrived in numbers and varieties that could not be absorbed within the balance of nature of the islands. The new species were more aggressive and gradually started taking control of the niche dug out by the species native to the islands. And they are still doing it today. The blackberry, an aggressive bush that spreads very quickly, advances inexorably across the landscape in the islands where it has appeared. It is one of more than 300 species of exotic plants that have been introduced in the last decade. A speed of invasion which the rhythm of evolutionary adaptations has found impossible to assimilate. The competition for the native plant's ecological niche is growing, although some of them have natural allies that enable them to spread widely far beyond the individual capacity of their fruit and seeds. This is the manzanillo. The sap from this tree is so poisonous that contact with it can produce very painful ulceration on the skin. Its fruits are also very poisonous for most animals, although not all. The so-called Galapagos, the giant turtles of the archipelago, eat these small fruits of the manzanillo without any trouble. Later, on their long pilgrimages through the island forests, they leave their compact deposits here and there. These turtles' digestive system is extremely rudimentary, so that after 1, 2, or even 3 weeks inside the animal, the manzanillo seeds reach the outside and colonize new lands which may be a long way from their original territory. The giant turtles of the Galapagos are very resistant to drought. Their metabolism allows them to obtain water from stores of fat and from the plants they eat on their slow journeys. But when there is water available, the big chelonians gather on the shores every day and protect themselves from the sun and get rid of any parasites by taking baths and caking themselves in mud. This male, weighing over 200 kilos, cools off by staying still in the pond. It seems prepared to stay there until the sun and the heat go down, but things are going to take an unexpected turn. From the inside of the forest, a female on heat responds to the call of the fresh smell of the pond. The turtle has not spotted nor smelt the motionless male, but when she starts to drink, her stimulating smell reaches him and produces an immediate reaction in the enormous suitor. The turtles mate in a very impolite way. When the female discovers that a male is approaching, she does not waste a second and takes off as quickly as possible. The male is bigger and faster and generally catches up with the female. Later, he will block her path with his 230 kilos in weight and will carry out the copulation in an act which more resembles rape than mating. In spite of its perfect adaptation to the environment and its great longevity, some turtles are said to be 200 years old, the giant Galapagos turtles have suffered an alarming decline in population levels, and their amazing capacity to withstand a lack of water and food is partly to blame. When ships started to arrive on the coasts of the Galapagos Islands, the sailors saw the giant turtles as a source of food on land and as a living food store for long voyages. One of these giants could go on for a year without eating or drinking, so they were perfect provisions for the sailors. In addition, these same ships whose crew members killed or made off with the turtles also brought invading animals with them that voluntarily or otherwise remained on the islands. Some of these, such as rats or pigs, have since then eaten the eggs of these giant chelonians. The result was that of the 14 races or subspecies which had been noted in the islands, only 10 have survived until today. Well, if you count Lonely Jorge. Inside the Charles Darwin Biological Station on the island of Santa Cruz, the last member of the subspecies from Pinta, the most northerly island of the archipelago, awaits his sad fate with patience. The Despite attempts to cross him with other similar subspecies, Jorge has rejected all the females. A reward of $10,000 has been offered for a pinta female, but no zoo has been able to find one among its animals. In 1981, turtle excrement were found on Pinta, offering a ray of hope to this last example of a biological prototype that took millions of years to finish. Maybe Jorge has still got a chance to find a mate before he dies. The animals which were bought by sailors reproduced at ease and upset the ecological balance of the islands. One of the most widespread and most damaging was the goat. Abandoned on the island to reproduce and serve as future meat supplies, the goats prospered quickly and have become a plague. Today, the same species that brought them in is trying to correct this mistake, and although the goat culling campaign is difficult, it is beginning to produce results. The controlled hunting of goats is permitted by the Galapagos National Park Services Department, who enlist the services of hunters. The hunters use firearms or, as in this case, surround the goats near the coast, and once they are tired, catch them and slaughter them. The youngest animals are sold as meat for human consumption and provide a source of income for the hunters and a source of protein for the islanders. But many old males are killed and abandoned so that the local buzzards may feed on their meat, so that in the end the goats do offer some benefits to the local fauna. The Galapagos Islands are a living, ever-changing system which is historically and geographically isolated and has only been joined to the rest of the world by man, the most aggressive species on the planet. From a strictly ecological point of view, we are just another species, and our appearance in Galapagos and the avalanche of immediate consequences would therefore not be more important than other episodes in the long process of adaptations to new events that the islands have experienced since their origins. But our species is not just another of those that arrived and will continue to arrive at the Galapagos in a natural way. We are the most aggressive, but we also have the knowledge and the sensitivity that enables us to conserve this strange paradise where we can study the mechanisms of the origins of life and the development brought on by the struggle for survival, a complex and intricate game in which our species is also immersed. Now, all efforts are centered on a common aim, to conserve the isolation of the islands and their biological communities as far as is possible. Only in this way can the intricate mechanism of natural selection be studied. And only in this way will the prototypes be preserved, those endemic species that arose after thousands of years of adaptive pressure on the different habitats of the Galapagos Islands. It makes no difference if they are iguanas, land-based turtles, finches, or these lava gulls, of which only 400 pairs are left. All of them are fragile gears in the hermetic mechanism of the Galapagos. All of them are equally important, equally necessary. Darwin came here in search of the literal confirmation of the words of the Book of Genesis, but Galapagos gave him their own answer. A view of life that would change our conception of the origin of species forever, and which would make him right. Here, both in space and in time, we feel that we are closer to that great event, that mystery among mysteries, which is the appearance of new creatures on the Earth.